Good day, students. Welcome to math.serve.com. On this tutorial, we're going to be going over how to solve system of equations using matrix equations, which involves finding the inverse of a coefficient matrix. Don't forget to visit our site at math.serve.com for a collection of a wide variety of tutorials ranging from algebra to calculus. All right, before we go into the example, I'd like to go over the procedure for solving matrix equations. All right, so let's say you have a system of equations and you express it as a matrix equation, which is going to be ax equals b. All right. So A is going to be the coefficient matrix. It's going to be the coefficient of all the variables. And then the variable matrix will be the variables that you have. And then B is going to be your constant matrix. All right. So the goal to solve a matrix equation involves isolating the variable matrix. All right. So in order to accomplish that, we're going to take advantage of the inverse of a matrix. We're going to be focusing on 2 by 2 matrices in this example. All right. So I would like to cancel out this coefficient matrix. Since we cannot divide matrices, what I'll have to do is multiply both sides by the inverse of the coefficient matrix. All right. So multiply the left side of our matrix equation by um, the inverse of the coefficient matrix, and then the same on the right side. One thing you want to note is that matrix multiplication does not commute, so you can't switch the order of multiplication. So if you're multiplying the coefficient matrix from the left, you have to do exactly the same thing on the right, okay? Now, when you multiply these two matrices together, you're going to end up with the identity matrix. All right, the identity matrix I times X equals A to the inverse of the coefficient matrix times B. Now, the identity matrix times any matrix is going to give you that matrix. That is why it's called the identity matrix. And then this matrix, this product right here, the inverse of the coefficient matrix, times B is your solution matrix. All right. So this is what we're going to be looking for, and then we will translate it back into the system, and then we'll solve it. All right. So let's take a look at the example, question number 1. Um, so the task is to express the given system, express the given system as a matrix equation, express the given system as a matrix equation, and solve. Okay. All right. So let's go ahead and take a look at the system of equations. What we're going to be solving is 5x plus 4y equals negative 14. Right. The second equation is 3x plus 6y equals 6. Okay? Remember, when you're solving systems of equations, you could have no solution, one unique solution, or infinitely many solutions. So you want to keep that in mind. Okay, now first thing we're going to do is express this system as a matrix equation. I'm going to extract all the coefficients and place them in a matrix. And that will be matrix A, the coefficient matrix. All right, so 5, 4, 3, 6 will formulate my coefficient matrix. Okay, so let's go ahead and extract them and place them in a matrix. So we have 5, 4, 3, 6. And then our variable matrix is simply going to be the two variables we have, x and y. And then our constant matrix is the numbers we have on the right side of our system of equations, which is negative 14 and 6. All right. So this is my related matrix equation. Now, with this matrix equation set up, we can identify our A our X and our B. Okay, so this matrix here, this is our coefficient matrix A, this is our variable matrix X, and then this is B. So the goal here is to isolate matrix X, the variable matrix, and then the matrix on the right side will tell us the solution to the system. X will be the value of the matrix on the top, and then Y will be the value on the bottom. So in order to do that, as we indicated in our procedure, we have to find the inverse of the matrix and then multiply both sides from the left by the value of the inverse. So we have A, matrix A is 5, 3, 4, 6. And we know the formula for finding the inverse. Let's go ahead and write down the formula for finding the inverse of a matrix. Formula for finding A inverse is 1 over the determinant of A, which is AD minus BC, multiplied by matrix A, where the diagonals are switched. So instead of AD, you have D and A, and then you take the opposite of the wings. So instead of B here, you have negative B, and instead of C here, you have negative C. So this is the formula for finding the inverse of a 2 by 2 matrix. All right, so in this situation, we can clearly see what A, B, C, D are. Let's go ahead and label them real quick. This is our A, this is B, this is C, and this is D. Now let's apply this formula to this problem so we can determine the inverse. A to the negative 1 is equal to 1 over the determinant of A, and the determinant, hopefully is non-zero, is AD 5 times 6 minus BC 4 times 3. Okay, so that's the determinant. The denominator is the determinant times, we're going to switch A and D, so that gives us 6 and 5, and it would take the opposite of the wings, negative 3 and negative 4. Okay, now let's simplify it further. We have 1 over 5 times 6 is 30. 30 minus 12 is 18. That times 6, negative 3, negative 4, and 5. Now this is a scalar multiple, so all we just do is distribute 1 over 18 to all the terms in our matrix. All right, if we go ahead and do that, remember we can simply put a 1 underneath all of these numbers, just expressing them as a fraction. And the way of multiplying fractions, you multiply numerator to numerator and denominator with the denominator. All right, so this will be 6 over 18. This one right here will be negative 4 over 18. And then down here, you're going to have negative 3 over 18. And then the last entry will be 5 over 18. All right, now let's go ahead and simplify that a little bit. We're going to have 6 over 18 is going to be positive 1/3. Negative 4 over 18. If you divide top and bottom by 2, you have negative 2 over 9. And then down here, if you divide top and bottom by 3, you have negative 1/6. And then down here, they're co-primes, so we just leave it as 5 over 18. So there goes your inverse matrix. Okay, so what are we going to do with the inverse matrix? Remember, to solve the matrix equation AX equals B, we're going to multiply the inverse matrix, multiply both sides by the inverse matrix from the left, like this. Okay, so that's what we're going to do with the inverse matrix that we just found. All right, so let's go ahead and do that. So we're going to have, let me write my inverse matrix in blue. Okay, so let's scroll up so I can see it. We're going to have A inverse, which is the matrix 1/3, negative 2/9, negative 1/6, and 5 over 18. So this is A inverse, the inverse matrix. That multiplied by matrix A, original matrix, coefficient matrix, which is 5, 3, 4, 6. Six. All right, so that's our coefficient matrix times the variable matrix, which is xy. And then that equals to the constant matrix. Well, the inverse matrix multiplied by the constant matrix. So we have the inverse matrix again, which is 1/3, negative 1/6, negative 2/9, 5/18. All right, so that multiplied by the constant matrix on the original problem, which is negative 14 and 6. Okay, so what's going to happen on the left side is that the product of the inverse matrix and the coefficient matrix is going to result in the identity matrix. For a 2 by 2 system, the identity matrix is you have 1 in the diagonals and 0 in the wings. All right. So basically, the identity matrix for any matrix, any square matrix, is the involves all the diagonals having a value of 1, and every other entry is 0. All right. Okay. So that goes your identity matrix right there. That's being multiplied by the variable matrix xy, and then the left side here involves us doing some work. We have to multiply these two matrices. So let's go ahead and do it on the side. I'm going to do it down here. So this is going to be a little bit messy because it involves fractions. So please pardon me. Okay, so the matrix on the left, I'm going to extract the rows, and I'm going to place them in this format: 1/3, comma, negative 2/9. And then the other one is going to be negative 1/6, comma, 5/18. All right, this is the xy. And then this matrix right here, I'm going to rewrite it in a horizontal orientation. Remember, when you're multiplying matrices, you multiply rows by columns, okay? That's why I have it set up in this orientation. Now think about this as xy. Xy, you multiply the x's and the y's. So in this situation, we're going to have 1/3 times negative 14/3, okay, plus negative 2/9 times 6/1. You multiply the x's and the y's like that, okay? So if you multiply them out, this one, let's see. Well, this is supposed to be 14/1, negative 14/1. I don't know where the 3 came from. So negative 14/1. So let's see what happens here. This is negative 14/3. And then this business right here, plus times minus is minus. This has a common factor of 3. 3 goes here 2, 3 goes here 3. So 2 times 2 is 4. 4/3. This it can combine these two to negative 18/3, which is negative 6. All right. Okay, now let's take a look at this one right here. The x's, multiply them together. You have negative 1/6 times negative 14/1 plus 5/18 times 6/1. All right, let's go ahead and simplify that as we did the other situation. So here, 2 goes here 3 times, and 2 goes here 7 times. So we have all right, and if we multiply them, we have 7/3, because minus times minus is a plus, 7/3. And then over here, 6 goes here once, 6 goes here 3 times. So plus 5/3. So 7 plus 5, that's 12/3, and that's 4. Okay? So on the right side here, we're going to have the product of these two matrices is going to be a 2 by 1 matrix, negative 6 and 4. All right? Now what do you get when you multiply this identity matrix by xy? You get the variable matrix, what you started with. So you have x, y equals -6 and 4. So what is the solution of our system? Solution of our system is x equals -6 and y equals 4. All right, so that's that. All right, let me show you how it's done with a graphing calculator. I'm going to be using a TI 83 Plus to carry out the computation. So all I just have to do is enter matrix A and B in my calculator and compute A inverse times B, and that will give me the solution. All right, so I'm going to go second function x to the -1, which gives me access to the matrix menu. And I like to edit matrix A. All right, matrix A has 2 rows and 2 columns, so I enter 2 by 2. Enter. Now let's enter the elements of the matrix. We have 5, enter 4 for row 1, and then for row 2 we have 3 and 6. So that's that for matrix A. Now let's go back and enter matrix B. Enter matrix B has 2 rows and 1 column, so it's a 2 by 1 matrix. All right, so the first element is -14. Enter. The second element is 6. Enter. So that's that. So just to make sure that we have our entries correct, I'm going to call matrix A and B and examine the outputs to ensure that they match these values right here. Okay, so let's go ahead and call matrix A, second function x to the -1, enter for matrix A, 5, 4, 3, 6, excellent. And then let's call on matrix B, second function x to the -1, scroll down to matrix 2, which is B, -14, 6, good. So what we're looking for is a solution to this matrix equation, and that is equal to A to the -1 times B. All right, so let's go ahead and find it. So we're going to compute A to the -1, second function x to the -1, whole matrix A, you append the -1 symbol there, and then we are multiplying it by matrix B. All right, enter, -6, 4. Let's see, is that what we have? Excellent, that's exactly what we have. So this is the solution to our matrix equation. It tells us that x is -6 and y is 4. All right, so that's that. But thanks so much for taking the time to watch this presentation. Really appreciate it. Do subscribe to our channel for updates to other cool tutorials such as this. And do post a comment to let us know what you think about this clip. More clips can be found on math.serb.com. Thanks again for watching and have a wonderful day.